Alright guys, today's goal. The learner will understand exponential and logistic functions. Okay? So some review. Evaluate the expression without using a calculator. Cube root of negative 125. Well, negative 5. I just think what number. So I know 5 times 5 is 25 times 5, 125, and it would be negative. So this one you can say cube root of 27 over cube root of 64, which is 3 over 4. Excuse me. This means cube root of 27 to the 4th power. Cube root of 27 is 3, 3 to the 4th, 81. That doesn't look so good. 81. So you got to do positive exponent. Well, how do you do when you have power to a power? You multiply. How do we make it positive? Take the reciprocal, move it down. Now, with the calculator, there's two options. You can try to find the nth root button, which I don't even remember where it is right now, or you can do this with your calculator. The 1/5 power. So that's what I always do. So it equals 1.3. Okay, so hopefully we remember these things. So let's get on. There we go. Exponential functions and their graphs. So what you'll learn about exponential functions and their graph, the natural base e, logistics functions and their graphs, and population models. And why exponential and logistic functions model many growth patterns, including the growth of human and animal populations. This is often used to make predictions, to make estimates in different areas, so this is something that's used a lot. Alright, an exponential function. Let a and b be real number constants. An exponential function in x is a function that can be written in the form f of x equals a times b to the x. So that's what we need to see, where a is a non-zero, b is positive, and b can never be 1. Okay? Because does 1 to any power change? No. The constant a is the initial value of f, the value at x equals 0, and b is the base. So we're talking like this. F of x equals 3 times 2 to the x. A would be 3, b would be 2. Okay? So it says determine the formulas. Now remember, it said a is equal to what x is 0. So since we know g of 0 equals 4, we know a is 4. Now watch. I know g of 1 is equal to 12. So what I do here, I say 12 equals 4 times b to the first. Well, divide by 4, you get b equals 3. So this one is g of x equals 4 times 3 to the x. So I look here, a is 8. So you get, and then I'm still going to use, so I know a is 8 because that's what it is. When x was 0, a was 8. So that's what a is. And then I'm going to use the 1 and the 2 here. So I know when x is 1, the function equaled 2 times 8 to the a to the first, divided by 8. you get a equals 1/4. So you get h of x equals 8 times 1/4 to the x. Okay? And this should have been a b, because we already found a. Alright. Yep, we got them right. So, that's good. Alright, exponential growth and decay. So how do you tell the difference between exponential growth and exponential decay? Let's look. For any exponential function, f of x equals a times b to the x, and any real number x, f of x plus 1 equals b times f of x. So what that's saying, if you have f of x equals 2 times 3 to the x, if I find out f of 1, I'll plug that in, you get 3 to the first times 2 is 6. Now watch. 1 plus 1, that's 2, but instead of plugging it in, what does b equal in this problem? 3 times f of x, which was what we just found, the 6, 18. And then if I did it using the equation, you get 3 squared is 9 times 2, 18. So, see how they work? That's what that means, okay? Now, if a is greater than 0 and b is greater than 1, the function f is increasing and is an exponential growth function. Exponential growths look a lot like this. Okay? If a is greater than 0 and b is less than 1, the function is decreasing and is an exponential decay. The decay functions look more like that. Okay? So do you see on this one how when we move positive infinity on the x values, it goes to positive infinity? Here, when we move to positive infinity on the x values, it's approaching 0. That's why it's called decay. But notice a is greater than 0 for both. If a is not greater than 0, it is neither exponential growth or decay. So to describe how to transform f of x equals 2 to the x into the graph g of x equals 2 to the x minus 2. Well, what if I told you this? F of x equals a times b to the x minus h plus k. We've seen these. What does that minus 2 up there mean? It means that it's shifted 2 units right. So let's look at this. Because if I said f of 0 equals 2 to the 0, I get 1. Now here, don't I need this? G of 2 to get 2 to the 2 minus 2 to get to the 0? See how x was 0 gave me 1? Now x2 gave me 1. That's what it's doing. It shifted it 2 to the right. Let's see. And there you go, because look, if I graphed that first point that we just did, there's where it's 1 there, but move 2 over. And if you think about 2 to the first is 2, move 2 over, and there I get my 2. 2 to the second is 4. Move 2 over. See how it's staying pace with that, with shifting 2 to the right? Okay. So describe how to transform the graph f of x equals 2 to the x into the graph g of x equals 2 to the negative x. Okay. So, let's think about this. if I had negative f of x, that meant reflection over the x-axis. What did this mean? Reflection over the y-axis. Okay, so basically, that's what it did. It reflected it over the y-axis. So we know it reflected over the y-axis, so let's see if we're right. It says the graph g of x equals 2 to the negative x is obtained by reflecting the graph of f of x across the y-axis. So remember these points we were just talking about there? 2 to the first is 2, 2 to the second is 4, 2 to the third is 5, 6, 7, 8. If you look and folded it right over this, don't we go 1, 1, 2, 2, and then 1, 2, 3, 1, 2, 3. See how they're the same distance from that axis of symmetry? Okay? So E, the natural base E. E is a number, it's like pi. E is this limit here. And if you look at the limit of that, it's 2.7124 blah, 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 blah. So that's what the natural base E is, and that is actually the inverse of the natural log function. So if you took the natural log of E, it equals 1. Or if you did e to the natural log of 1, it's 1. So those are inverses of each other. Okay? So, because natural log is considered log base E, which we'll be getting into. But alright, so I'm just introducing what the number is. So exponential functions in the base E. Any exponential function f of x, a times b to the x, can be written in f of x equals a times e to the kx for any appropriately chosen real number constant k. Notice how a is still greater than 0 for both. If k is greater than 0, exponential growth. If k is less than 0, exponential decay. So let's look at this. Here's the shape of these graphs, okay? Because again, if x is 0, anything to 0 power is 1. And then these are always e to the k. So what it's saying is if you had f of x equals e to the 2x, you plug in 1 for x, it's going to be e squared. 1 comma e squared will be your point. Okay? And if k is less than 0, so if it was f of x equals e to the negative 2x, it means it's going to be reflected again over the y-axis, so it flips it over. Okay? So, we'll see some examples. Just understand the shapes and how e to the x can also be exponential growth and exponential decay. So it says, describe how to transform the graph of f of x equals e to the x into the graph of g of x equals e to the 3x. So remember when we learned f of x equals x divided by c? Well, here it's kind of like f of x equals e to the x divided by c. So how do you get 3 there? Well, it's because it's x divided by 1/3. So this was a horizontal shrink by a factor of 3. Okay? Let's see. So describe how to transform the graph f of x equals e to the x into the graph of f of x equals, or g of x equals e to the 3x. It's obtained by horizontally shrinking the graph by a factor of 3. Okay, so there we go. So hopefully we're starting to see that no matter what the function is, when you identify like the x or the x minus h plus k, those things, they're still the same thing, okay? So logistic growth functions. Let a, b, and c and k be positive constants, with b being less than 1. A logistic growth function in x is a function that can be written in the form of f of x equals c over the quantity 1 plus a times b to the x, or f of x equals c over the quantity 1 plus a times e to the negative kx. So, where c is the constant and the limit to growth. So, get your calculators out. I'm going to show you what this means. F of x equals 3 divided by 1 plus, it says b is less than 1, so 3 times 1/2 to the x. Okay? If you enter that into your calculator, and you look at the graph, it's going to look something like this. See how this stops and levels off at 3? That's the limit to the growth, because the constant up there was 3. Okay? So if you have an equation set like that and they're asking you a limit, well, the limit to growth is 3. Alright guys, we'll see you in class.